maybe we should get going. All right, excellent. Thank you very much, everyone. So welcome back. Welcome to the sixth joint Symposium on Social Robotics 2021. I would like, on behalf of the organizing committee, welcome you all to this session. And we are looking forward for another interactive session where we can exchange ideas, we can learn from each other's experiences, and get inspired. So I will start by just giving you a brief introduction to how this session will look like. So we will start with a welcome note given by Professor Hassan Nabuda. He's the Dean of the College of Humanities and Social Sciences. Then we will have a special presentation for a special issue by Professor Capoccio. Then we will move on to a keynote, and we will look at social robotics from an interesting perspective, the philosopher's, let's say, perspective. And we would wrap up with another panel discussion, which will hopefully take a more positive, let's say, perspective to the COVID-19 pandemic and try to look for applications or emerging applications or potential opportunities that probably have come with the pandemic and maybe have inspired us beyond. So with that, I would like to start by saying, on behalf of the organizing committee, we're very delighted to have Professor Hassan Nabuda, the Dean of the College of Humanities and Social Sciences, to give us the welcome note for this session. Thank you very much, Professor Nabuda.
Thank you, Dr. Muhammad. It's my pleasure, actually, and my thanks to all of you. So, as I said, either good afternoon or good morning or even good evening. I think we have some participants from Australia, as far as I know. So I am delighted to have this opportunity to speak to you all, and on behalf of the College of Humanities and Social Sciences, to welcome all the speakers and other participants to this sixth symposium on social robotics, organized jointly by the two colleges and coordinated with the New York Abu Dhabi University. I have been very pleased to see this symposium growing since its first edition and attracting an ever larger international audience. At CHSS, we are proud to be involved in this event. My colleagues and I believe that our disciplines will play an important role in the robotics revolution and in the quest for socially capable artificial intelligence. If robots are becoming more and more intelligent, it is mainly because of the efforts made by engineers and computer scientists. But if robots are to ever become capable of living and work with us, creating opportunities and jobs for the new generations, enriching our culture and improving the quality of our lives, that is only because we have developed an appropriate awareness of the ethical, social, economic, cognitive, and psychological contexts in which technology is embedded. Now, in the face of the ongoing COVID pandemic, which has changed the way we live in profound ways, the need to consider these wider issues is more pressing than ever. Many of you will be aware that the government of the United Arab Emirates has declared that artificial intelligence and automation to be a strategic priority for the development of a knowledge-based economy. As a college, CHSS is particularly committed to promote the progress of our society through innovation and the development of technology. At the same time, we have a responsibility to preserve the memory of the past and the legacy of our culture with its values and traditions. I will end by thanking you all for participating in this event. Even though we are not able to meet on campus on this occasion, I trust that you will enjoy successful and productive discussions. I send you my very best wishes and thanks to all of you. Thank you, Dr. Muhammad.
Thank you very much, Professor Nabuda, for this very warm note and very inspiring also comments about the past and the present and the future. We really highly appreciate it, and we appreciate the support of UAE University in this event. So with that, I think we will move with the second activity of this session, and this will be a presentation by Professor Capuccio about the special issue that hopefully is coming up in the International Journal of Social Robotics. Professor Capuccio, the floor is yours.
Thanks a lot, Dr. Eid. And also, I wanted to thank personally Professor Nabuda for his introduction, because his words were very inspiring. And I think they nicely introduced this session, which is mainly focused on topics related to humanities and social sciences, because mainly in this session, we're going to focus on ethical issues, psychological issues, societal, and even issues of politics and public policy, because as you know, today the regulation of artificial intelligence is a priority for all nations and major organizations. I like to say one thing that I miss of Lane is the very nice atmosphere that is very conducive to discussion, interdisciplinary discussion and exchange of ideas, which is something that is very important for our symposium, because as you know, it's about this combination of different competences from IT and humanities. And in particular, so now I'm going to talk about this special issue, which is a publication that came out just today. So I was informed by the Springer editor of this journal, International Journal of Social Robotics, which is maybe the main publication in our field. So this is a special issue that we started editing 3 years ago with a public call. And the title is Virtuous Robotics, Artificial Agents and the Good Life. And in this, so this was a call that we opened to all our colleagues from different disciplines, so philosophers, roboticists, and so on. But the idea of this special issue of International Journal of Social Robotics started with a discussion that we had, I think, during the second edition of the symposium. In particular, there was a panel discussion with Ron Chrisley and Steve Torrance and Blay Whitby and Riccardo Manzotti, if I'm not wrong. And it was dedicated about virtue ethics and the application of virtue ethics to social robotics. And in particular, we discussed issues such as, are robots going to corrupt our moral character? Is it possible that because we're exposed daily to interaction with robots, we will become more arrogant, lazy, and things like that? Because after all, robots, they represent to us something like slaves. No? So in the end, to become used to live with slaves is make us entitled, make us more arrogant, right? Maybe it creates biases, it creates prejudices of some kind. So we have reasons to be worried about robots having a negative effect on us. But then we say, okay, we discussed that panel discussion was seminal, was very interesting. But then we said, let's discuss the opposite side of the story. Can robots give us a help to cultivate ourselves and flourish as human beings? Not only in the sense that they will make us richer or that they will give us utilitarian advantages of some kind, like helping us in our workplace, and so that's obvious. But is it possible that robots will help us improve from a moral point of view, to better ourselves, to develop those qualities, those virtues that make us good people, right? So we started investigating that issue, and that it went on through different, the following editions of the symposium. And also, I want to remember a couple of, so there was a paper that I co-authored in 2018 with Dr. William MacDonald, who was the chair of philosophy at the time. And then we had also a panel discussion at Western Sydney University, organized by Omar Mubin. And then we had other discussions. So I want to say this special issue that you can find today, if you Google, if you go to the web page of International Journal of Social Robotics, is the outcome of this process of this exchange of ideas that we had through the past 3 years, I would say. The first paper, I just want to summarize quickly. There is a proposal. It's a little bit our manifesto. So this paper was co-authored by me, Eduardo Benitez Sandoval, Omar Mubin, Mohamed Obaid, and Mari Velonaki, who is the director of the Creative Robotics Lab at UNSW Sydney. And the idea is that, so we have an original proposal in the field of machine ethics. Machine ethics is the field of study that the field of research that studies how machines, what are the preconditions for machines to make ethical decisions, and how we should design robots so that they're capable to make the right thing. Usually the two main approaches are, let's say, the approaches in machine ethics, they're inspired by two theories of normative ethics, which are consequentialism and deontology. They focus mainly on the maximization of the advantages for the largest number of people. This is consequentialism. Deontology, on the other hand, focuses on the duties and obligations and the respect of the rights and the entitlements of people. So to build a robot according to the principle of consequentialism means to build a robot that makes a decision that benefits the largest number of people, or that minimizes the damage for the people. To build a robot according to the principle of deontology means to build a robot that is respectful of the rights of people. So a robot that has built in some mechanism that prevents it from offending or limiting the liberty of other people, for example. These lines of research are very interesting, very productive. We wanted to develop a third line, something completely different, because we must acknowledge the difficulty today to have a robot that can make ethical decisions following such a principles, because a robot, an artificial intelligence, is not capable to distinguish, for example, this is a classical example, a funeral from a birthday party. If a robot cannot distinguish between two different social contexts like this, how can it possibly make a decision that is respectful of the social conventions, of the moral norms of human beings? Our proposal is we build robots designed not to make ethical decisions on our behalf, but designed to help us ourselves improve our moral character and then become able to make the right decisions at the right time. So the idea is that imagine people who are struggling to develop a better lifestyle. So people who are struggling, like they want to get rid of some vice, like smoke, or they're doing some diet because they have a medical condition. Or imagine students, they're struggling because they want to succeed in their studies, so they need to dedicate all their attention, all their effort to their studies. Imagine sport people, athletes, they're under pressure to train themselves in the best possible way. Imagine that now when they fail, it's not because they don't know what the right thing is. They already know in their mind, they know what is the right thing and what is the wrong thing, but they don't have the support of a person who is next to them, telling them, reminding them, you need to do this, you need to stop doing this, you need to be aware of what you're doing. So our idea is that design robots that play exactly this role, the role of moral assistants, not in the sense that they are moral authority. Robots don't know anything about moral, but they can help you to remember what you already know. So in this sense, the interaction with robots is designed to develop awareness of the duties and the values that inform our choices and our lifestyle. So anyway, this special issue, there are 10 contributions from different authors. Some of them are very influential philosophers of work in the field of philosophy of technology and virtue ethics, such as Rob Sparrow, who is Australian, Mark Hockelberg, who is based in Austria. And then there are also different contributions from an applied perspective. So they illustrate basically how a robot can be designed in order to produce certain beneficial effects on the behavior of people. Just the last paper in the collection is a pepper robot designed to help to remember to teach students how to be more respectful of the environment and acquire better awareness of the value of recycling. So it's a robot that helps people to recycle garbage mainly, but from the point of view of promoting a moral attitude in the people. So I just want to I want to mention this this as a positive outcome of our previous edition of the symposium, which we are proud and it's a collective publication that represents a collective effort and the contribution from many of the speakers who participated in the previous editions. And again, it's a result for our sponsors, who are the College of Humanities and Social Sciences, the College of IT, and NYU Abu Dhabi. I think, yeah, I just want to invite you to have a look at this special issue if you go online. And now I think I spoke enough, and I would like to introduce the keynote speaker. I personally want to introduce him because he's also a philosopher like me. So I want to say a couple of words because he is a philosopher who has inspired many other philosophers working in our field. Ron Chrisley, who is currently reader at the University of Sussex, where he has well, first he had been the director of the Center for Cognitive Science for many years, and at the moment he's a reader at the Sackler Center for Consciousness Science. He was educated in Oxford and Stanford. He has a double background in philosophy of mind and computer science. And it tells from the kind of research that he does and his publication, he produced very important contributions in the field of philosophy of cognitive science and the philosophy and theory of artificial intelligence, in particular focusing on issues related to artificial consciousness and foundational notions related to artificial intelligence and the problem of embodiment in human-robot interaction. So the title of his keynote speech is Grounded Social Understanding with Artificial Agents, How Much Embodiment is Enough? And I'm very pleased to give the word to Professor Ron Chrisley. Thanks.
Thank you very much for that kind introduction, Max. And also thank you to the other organizers for making this event possible and inviting me. Also to Professor Nabood. I've enjoyed my previous visits to UAEU and NYU in Abu Dhabi, and I look forward to the time when we can do this non-virtually, but the virtual meeting is itself a treat too. I'm just going to press on. I have a lot to cover. I am going to be looking at a problem that exists for current fashionable approaches to AI, fashionable approaches to machine learning. They have a lack of understanding, and their progress has been impressive, but I believe it's limited by this lack of understanding. And there's a, now getting rather old, but a kind of well-known proposal for how this lack of understanding might be overcome, or a diagnosis of why current AI systems and good old-fashioned AI systems had a problem of understanding, and that is that they're not sufficiently embodied. And so there's been proposals for that such systems should be grounded, maybe robotically grounded, should be embodied in some way for there to be true understanding and further progress than we've seen already. And some of the people who participate in these symposia here, the JSSR series, have been made very important contributions to this, to advancing this idea, to coming up with robotic systems that are more grounded. Some of the people who are who've spoken today and will speak in panels later in the next panel. So I just want to comment on that and then point out that there's a twist that's being proposed by some people to this old idea, a kind of relatively newer twist that maybe we can get by without robotic embodied grounding in order to provide the kind of meaning and understanding we need for truly intelligent AI systems. Maybe we can get away with virtual embodiment instead. So I want to consider that proposal and look at some dimensions, look at in a little more detail about what that proposal might amount to, some variations on it, and basically assess whether or not what is virtual embodiment? Is it a contradiction in terms, and can it provide what AI needs? The upshot will be that more of a positive conclusion, I think, than say Christoph's keynote, although maybe that's not saying much, is that social robots and social robotics may be required for the advances in AI that so many are seeking. So maybe there is a future after all, even if we don't yet know how to achieve the kinds of advances, maybe some kind of cooperation between the currently disembodied approaches in machine learning and social robotics might provide the way forward. So I'm not going to spend much time on this fact that deep learning and related technologies have been very successful in the last 5-10 years even. So I will just pass over it after having mentioned it, but I'll just point out that it has to do with mainly a kind of sophisticated statistical inference powered by massive data sets using fast hardware. That's the recipe for the current success. But there are limitations to this approach, and one slide can't do justice to all the now well-known, becoming more well-known limitations to the current success in AI and machine learning. But for example, there are failures of perception as indicated here. These AI systems that look like they're very, very good at classifying things, like classifying animals into different categories like pandas and sloths and cats and dogs. Nevertheless, we can show that they don't give common sense perceptual results. So If you just add a little bit of noise in the right way to a photo of a panda, you can make that system classify the panda as a gibbon. Or if you do the same thing to a picture of a sloth, you can make that what we thought was a really good image classifier. It can end up classifying the same, the very similar, what we think is a very similar, that is indistinguishable photo of a sloth as a race car. But it's not just that. There are all kinds of limitations that I can't go into. They lack abilities to reason and plan and use variables, etc. So there's a general acknowledgement that in order to make the kind of AI systems a lot of people are interested in, especially AGI, artificial general intelligence, if such a thing is possible, we're going to have to do something different. Something needs to happen. So I want to focus on a diagnosis of the failure of these systems as being a failure of understanding. So these systems don't realize, they don't understand anything about the things that they're classifying or the patterns they're recognizing or responding to. Those patterns are significant to us, but they're not significant to the AI systems we currently build. So these systems can distinguish cats from non-cats in a sense, but they don't really understand what cats are. So you can train a chicken to learn to peck at a lever that has a photo of Halle Berry over it rather than a photo of Jennifer Aniston or something like that. But it doesn't mean that the chicken understands that those are people or who they are or anything. It's just learned to discriminate the stimuli. So AI systems are going to have to be more than mere pattern discriminators if they're going to achieve the kinds of behavior that we're interested in, intelligent behavior that we're interested in. So how to do that? Well, some would say just continue business as usual, more of the same, please. We just haven't done it enough. We need more data sets, bigger data sets of the same kind that we've had before. We need just bigger, faster GPU clusters, more of them, please. And maybe, okay, maybe there'll be a few algorithmic tweaks along the way, but the general setup will be the same. I'm here to suggest that that's not a very good idea for looking at significant progress in AI, but I have rather a different diagnosis of what's going wrong here. These AI systems, despite the lessons that were learned, supposedly learned, or the lessons that were at least taught as far back as the 80s with, say, Rodney Brooks and other people emphasizing embodiment in artificial intelligence. Nevertheless, these current AI systems, machine learning systems, are once again embracing a disembodied understanding of what intelligence is, and therefore a disembodied notion of what of their system building. So their systems are disembodied. Let me specify just one example, one concrete sense in which you have a disembodied approach. The data sets themselves are typically disembodied. What does that mean? Well, the data sets that power deep learning typically are something like what you see on the right. They're objective in the sense that the data are independent of any agent's sensory motor perspective. Well, no data set is really independent of any there's some agent that produced that data set, or there's some agents that were involved in it, so not entirely independent, but it strives as much as possible to be as independent from any particular agent's sensory motor perspective on the world as possible. Of course, that's not really possible. Every category we use is a product of our sensory motor embodiment, but nevertheless, certainly it's independent of the AI system that's using this data set. It's independent of its sensory motor abilities, if it has any. And also the data tends to be disembodied in a different sense, which is the data tends to be independent of any one agent's spatiotemporal location. So it's meant to be, it's like a view from nowhere presentation of the world. These are the facts, and they're facts that hold true no matter who you are, where you are, what time you're considering them, etc. So in this sense, the data sets are disembodied. Is anybody else hearing another voice other than mine? But more precisely, it's not a matter of embodiment versus non-embodiment. That is our embodiment, and therefore the embodied meaning that our symbols have, and then the disembodiment of the systems that are using it. But really, since anything that gets anything done in the world must have some kind of embodiment, it's more of a, maybe you could best think of it as an embodiment mismatch. So the data that these systems are using are not the kinds of data that are appropriate for the system that's doing the reasoning about them. It isn't grounded in the AI system's very alien forms of physical existence. And that's almost always because at least current, most, there's some exceptions perhaps, but the most, the kind of the typical AI machine learning system today has nobody to speak of. And so it's very unclear how to talk about its location, perspective, sensory motor, engagement with the world, etc. Well, as an aside, I'll just say, what would a non-embodied data set look like? If I'm talking about how could a data set not be disembodied in the sense that I'm criticizing current data sets for being? Well, I think data sets could be less disembodied. So for one thing, typically a data set is a mapping from inputs to outputs. Let's accept that for the moment. But those inputs and correspondingly the outputs don't have to be a bag, just a kind of collection, unordered set of atemporal, unrelated items. So there are some kinds of AI machine learning systems where the inputs are, if you want to think of them as inputs, are themselves the results of the agent encountering the world as a response to its previous engagement with the world. So it's not just that these inputs and outputs are independent, input-output pairs are independent of one another. The input that I'm getting at this time is a product of how I responded to the world a second ago and the input that I was receiving at that time. I actually choose, my body selects out input depending where I look and what I'm attending to and where I am. So that just having that kind of structure in your data set will provide a kind of grounding and embodiment that current data sets cannot express. In fact, maybe we should not even think of them as data sets. Yes, there's something crucial to AI systems, this interaction with the world and improving one's performance through interacting with the world, but it might not be very useful to just cut out a slice of that interaction, the world, roughly the world part of that interaction, and say, okay, that's a data set, because it's not going to be something that's portable to another agent or to a different time. It's very dependent on a particular dynamical route through the environment by that agent. So it might not be a useful way of thinking at all. So it's the combination of disembodied systems learning from disembodied data sets, which I think really prevents them from acquiring more than a superficial understanding of the world. What capacities, what distinctions these systems can make are entirely parasitic upon our ability to discriminate objects in the world. So we can understand what a photo of a cat is versus a photo of a non-cat. We can properly put those different images into different sets, and then we can train an AI system to make that discrimination. But the AI system doesn't acquire the understanding that we used to separate this data in the first place. So they're not distinctions for that AI machine learning system. They might be distinct discriminations it can make, but it isn't its own isn't its own distinction that it's somehow earned or somehow needs to make in order to make sense of its world. So in that sense, the distinctions aren't grounded in the sense that Stephen Harnad introduced in 1990 when he wrote about the symbol grounding problem. So current AI systems that are like this are mere symbol manipulators. They manipulate symbols that are significant for somebody else, namely humans, but they're not meaning generators or understanders. They can't generate their main their performance does not consist in any ability to generate meaning or be a true understander. So some might respond to this by just saying, well, that doesn't matter. Look how far symbol manipulation can get you. And it's true, there's some interesting apps and technologies that don't require any kind of deep understanding, that only require some superficial kind of understanding that this kind of approach to AI machine learning can provide. But how far will that really get you? How far can you go with that? When do you actually need, in order to get the right performance that we want, when do you need to have an AI system that has a less superficial understanding, that is capable of generating meaning or understanding? What applications might crucially require meaning generation and understanding? Well, that's where we have our first mention of social robotics, I think, because I think once you have, maybe if you have an AI system that is, it's hard to imagine one, but its relation to us and its dependence on our sources of meaning is minimal, then maybe you can imagine that it would need very little by way of meaning generation, or if it's not really meant to be intelligent at all, it's just meant to be some kind of tool against which we react, then where we're doing all the intelligent work, then okay, that's a very valid approach to doing AI, and I think it's a crucial component of the human-centered approach to AI, which sees it as AI is not really being intelligent, but merely being some kinds of assistive devices to get us to amplify and develop our own intelligence and creativity. But if you are interested in AI systems that are themselves, well, if you're interested in AI systems that are going to be more of an active participant, then it looks like you're going to need it to be a meaning generator or understander, because that's many of our social interactions are constituted by meaning generation and understanding. And like I say, that brings social robotics onto center stage, because that's going to be the case where you have artificial systems that are at least in the right part of the ecosystem to acquire that meaning and deploy it in a way that's going to be, to interact with fellow meaning understanders and meaning generators. And it's not just, let me go back, it's not because of language. So language is an obvious way in which, if you want to understand linguistic utterances, want to interact with people linguistically, then it really helps to understand what they're saying. We all have been frustrated by the stupidity of voice assistants that don't understand what they're talking about. But even with non-linguistic cognition, you have a social structuring of the world. Even when we're not interacting, when we're just interacting with the door or food or pets, all of those things are social objects in a way. They're socially constructed objects and play a role in a social nexus of meaning. So an agent that doesn't understand how to, that has no social existence and no ability to generate or understand meaning in a socially contextualized way is not really ever going to get what we mean by food or pet or door. And so it's going to be always performing in a way that we find unpredictable, unacceptable, undesirable. An aside here about language is that, yes, language is grounded in our embodied existence, and it rises out of metaphor that's embodied, and on the one hand, it would seem to be very much a case where an AI system is going to have to, that's linguistically competent, is going to have grounded meaning. But on the other hand, one of the purposes of language is to transcend that embodiment, is to take that kind of grounded understanding and decouple it from the particularities of the context and the situation, and allow it to some information to be applied in a quite arbitrary situation. So that's one of the triumphs of language, is to, in a way, exploit embodiment in order to transcend it. So because of that feature, I think some people get distracted. That's all they forget about the first part, about language being grounded in practical activity and meaning and embodiment, and just focus on its portability and its abstraction. And so they're tempted to just go directly for the linguistic ability without having done the former grounding. So that there's a strong temptation to fake it. So one might think, okay, yes, you're right, Ron. If you want to build a dancing robot or dancing agent, yeah, it better be robotic, because dancing is essentially embodied activity, and you know. But why would I have to robotically ground my chatbot? Language is portable, as you say. It transcends context, so I don't need to worry about the embodiment. I think that's the mistaken view. I think that's getting it wrong, and that's why we see this kind of partial success but partial failure of current AI systems that dabble in language. They manipulate things that are meaningful for us, and they look at how we manipulate those things, and then they try to apply statistics to do the same thing without actually having the understanding or the embodiment that would that is the source of our the statistics that our linguistic use displays is the result of our embodied understanding of the language. And these systems are trying to fake that and just get the statistics without somehow modeling the process underneath. And this isn't new. You could think of Weizenbaum's ELIZA program as doing the same thing, only in a very poor way. So what's striking about the models like GPT-3 from OpenAI is that they can be much better than Weizenbaum superficially. Weizenbaum's ELIZA program, I mean, Weizenbaum was great at using language. He was a native speaker of English, but ELIZA, it has been improved upon, but still, it's like, you know, climbing a tree to get to the moon. Yes, you're closer, but there's still a fundamental reason to think that you can't get there that way, at least according to me. So I include this example here to show how GPT-3 can get it so right, but also get it so wrong, which reveals, they're howlers that reveal that there wasn't any understanding, even in the cases where it was getting it right. So I'm not denying, again, that there are a lot of great applications for faking it. Faking it might be sufficient for a lot of interesting technologies and business models. As a matter of fact, coming up with use cases for which faking it is sufficient for success, I think, is a big component of many of AI's business success cases. But it's really not sustainable, and it won't lead to the kinds of AI systems that I'm concerned about today. And you can think of, we have a parallel here with the uncanny valley, the annoying valley. There's the annoying valley is that point of linguistic competence, including vocal quality, that's sophisticated enough to invite a prima facie plausible attribution of understanding, but it's not good enough to actually sustain that that attribution. So I think that's what I was talking about when I mentioned voice assistance. So the corollary of that is that if you're going to make a non-annoying linguistic agent, maybe it'll have to be embodied. It'll have to be a grounded meaning maker, meaning understander. And as I said, people, there are very clever people, talented people, some of whom are associated with these meetings, and some of who have been present today and have spoken already today, who have been involved in such a project. So far, I haven't told them anything new. They might be cheering me on, but they're wondering why I'm presenting their work, maybe. So we have examples from iCub project or Luke Steele's Talking Heads project of trying to ground, in particular, linguistic meaning in being an embodied robot. Okay, so very admirable, and I think right-headed research programs. But perhaps grounding isn't enough, because robotic grounding of meaning poses its own problems. So yeah, once you give up cheating by just assigning human meaning to AI symbols, but rather force your AI to earn them through honest toil, as Stephen Harnett puts it, then the hard work, the right work and hard work really begins. So for one thing, the meanings that are justified by a robot's embodiment are likely to be substantially different from ours. Robots are not humans made in a different substrate. They're very, very different from us in their embodiment. So their meanings that are grounded are likely, are very different from ours. And that could be hard to see if you have a simplistic theory of representation or theory of meaning. So the philosophers are the ones who maybe are best at understanding the subtleties of different kinds of meaning and how they depend on embodiment, whereas the people actually out there building the interesting systems, that haven't necessarily wasted 10 years learning about the different theories of meaning that there are. So often you'll see people just using a kind of usually implicit, simplistic theory of meaning where that's exclusively causal. So something means X if it's caused by X, which ignores, say, the purpose to which the representation is put rather than what caused it. It tends to be exclusively referential, meaning it's just what the thing is about rather than how it's presented or the mode of how that thing is presented. So, we famously or notoriously have many different ways of thinking of the same thing and representing the same thing in different aspects. And it also tends to be exclusively conceptual. And I can't go into detail about this, but I think there are non-conceptual or pre-conceptual ways of representing the world that are hard to talk about, and so they tend to get ignored when people are doing their grounding of meanings in robots. So achieving this alignment and understanding can be very hard. I mean, Wittgenstein thought it wouldn't be possible. I guess he's, and so maybe it's not just lions, but maybe robots. The hard work is to make Wittgenstein wrong with respect to robots and say, well, if we build them maybe closer to us, then maybe we can understand them. But also we need to make sure they can understand us. So there's a double challenge there. And no doubt the solution will involve us adapting to the robot. We're the sophisticated, a much more sophisticated, more sophisticated intelligent agents in this equation. So probably we won't be meeting each other halfway. We will be bending over backward to try and make sense of these robots and try to make ourselves understandable to the robots. And that shouldn't be neglected as a dynamic that might contribute to the success of this kind of meaning conciliation between robots and humans. But in addition to that, it will also involve a sophisticated theory, as I said 2 slides previously, not 1 slide previously, an understanding of how agents can understand each other and coordinate, even though their meanings are not exactly the same, even when they're quite different because they have different embodiments. And also, of course, actual engineering work, hard engineering work that takes those 2 theoretical points and actually turns them into concrete working systems. And that's hard work, particularly hard work. So some people have been tempted to take an easy way out. This is the new twist I mentioned. An easy way out, rather than having to do that hard robotic work, why don't we instead, because look, building robots is slow, it's hard, it's expensive. Training robots is slow, hard, and expensive. Why not do away with actual bodies and instead have virtual bodies? Do away with the actual world and instead have a virtual world and use that to ground meaning rather than using an actual body or actual world to ground meaning. So the question is, can this approach provide the required grounding in virtually embodied meaning without the inconvenience of actual embodiment, that is robotics? And some prominent research groups are betting yes, they're taking this approach. So this graphic is from a paper from a few years ago from DeepMind, but this looks to be a trend that's happening more and more. So the great thing is that they realize that they need to go beyond the mere superficial statistics collecting, but the questionable assumption here, I'm not taking a stance in this talk on, I'm not saying that this is a mistake, but it needs to be, there needs to be further investigation as to what's going on here and whether or not it could possibly work, rather than just a hubris of saying, well, of course this is going to work. What's interesting is that there's some surprising philosophical support for this idea that a virtual body is just as good as a body for generating meaning. So you wouldn't necessarily expect support for that view to come from a prominent philosopher in the E4 cognition community or from a prominent anti-AI philosopher, phenomenologist philosopher, but that's what you have. So here's a quote from Andy Clark, Matrix, so both of these quotes are from a volume about the Matrix films and the predicament of the people in these simulations, or these simulated agents. So Andy Clark says, Matrix-based human intelligences would count as being fully and richly embodied as you and I. And he doesn't mean because there's a body there dreaming or experiencing the Matrix simulation, but rather because of the Matrix simulation itself. And similarly, even the Dreyfus brothers say, who are phenomenologists and scholars of Merleau-Ponty, say that the people in the Matrix world are not brains and vats any more than we are. They are people who grew up in the Matrix world, and their experience of their Matrix body and how to use it makes that body their body, even if another body they can't even imagine has in its skull the brain that is the causal basis of their experience. So that's two strong votes in favor of virtual embodiment being sufficient for meaning grounding. And this is something that maybe comes up in this time of COVID, where a lot of us have been experiencing disembodied interactions. We've been talking about that and the drawbacks of that. And in particular, there's been a lot of disembodied teaching and tutoring. Disembodied, relatively disembodied. I mean, not, obviously people still have bodies, and there's actually some kind of sensory motor interaction with a very different kind of embodiment, and one that's more digitally mediated than is usually occurring. since that interaction is, let's say, purely digital, one might think, well, now we see that even though it might not be as good as in real, normal, embodied, in-person tutoring and teaching that is purely mediated by this digital technology is possible. So perhaps we could have purely virtually grounded AI tutors that would function well. So yes, there are, prior to COVID, there have been companies that are looking at this idea of having virtual AI tutors, and Corbit is a company with a product called Corby. That's an example, but I don't have time to really go into more detail about that. But these attempts raise general questions about how is such understanding to be grounded, and I'm winding up here. I'd like to close with this kind of sketch of the different options for how virtuality might play a role in grounding AI systems of the near future, so that they're more intelligent and understanders. So there are two key choice points that involve virtuality in this case. One is the embodiment of the agent at runtime. Is that a robotic embodiment or a virtual embodiment? And there's the embodiment of the agent during training. Is that a virtual embodiment or an actual robotic embodiment? So what I mean by virtuality at runtime is just that you'd have, when the student is interacting with the tutor is not a robot, it's rather a virtual agent. Maybe there's a minimal robotic, I mean, it's hardly worth calling, there's a minimal embodiment in the sense that there's a screen, maybe a voice from a speaker, and the student can, maybe type on the keyboard, click on the mouse, say something in the microphone, but that's the extent of the sensory motor interaction. Now, as an aside, I don't want to spend a lot of time on this because it's just strange, but I just thought I would mention it. There's a variation of this, which is an echo Borg, which is a concept I've come across only in the last month or so, which is where a disembodied AI uses a human as its embodiment. So the disembodied AI whispers, it's kind of the disembodied AI kind of whispers in the earpiece of the human, and the human says what the AI system is telling it to say, which avoids problems of the realism of the interface, and is, well, anyway, I'm not going to really address that seriously in any of my conclusions, but I just thought I'd mention that kind of weird mixed case. The second dimension is virtuality during training, and independently of the kind of embodiment you have at runtime, there's the question about whether during training the agent is really embodied in a robot and is learning about the world through that way, or whether it's merely virtually embodied. So you might think that the only way a virtual tutor could succeed is if it at one time was a robot, and that while it was a robot, it actually acquired embodied meaning, and then now it has it, and it doesn't have to continue having its robotic embodiment in order to exploit the meaning and understandings that it acquired as a robot. Or one might think that you could virtually train a controller that you would eventually implement in a robotic tutor, and that you don't need to have slow robotic training. You can have virtual world training and then transfer that controller to a real robot. Either way, social robotics will be crucial. The concepts, the techniques of social robotics, even in the virtual cases, will be crucial because you will be needing to create a virtual robot. And yeah, there's some maybe aspects of social robotics that won't be relevant, but a lot of social robotics will be. And here's just a chart of the 4 different possibilities, but as I'm out of time, I'm not going to go over them as they're just kind of repeating what I've already sketched before. Finally, last slide. One possibility is this, that one technique that might minimize misalignment between the grounded meanings that the, say, virtual runtime AI tutor has, and the student has, the embodied student has, is to try to have the student meet the AI tutor on its own virtual turf. So give the student a virtual reality avatar, and so the student can be in the world that that is significant for the artificial tutor, so that there can be an exchange of shared meaning. On the other hand, the actual embodiment of the student will obviously be ever present, and motivational considerations are some of the biggest challenges and some of the most important issues in education, including computer mediated education. So I'm not sure those will be addressed at all, and so there's an outstanding problem there. But perhaps there could be a hybrid approach where there's a personalized virtual AI tutor, but also a general human tutor to deal with the motivational issues, but not possessing any curriculum or tutorial skills that are tailored to the student as the AI system might be. So there might be some advantages to a hybrid approach. But with that, I will finish. Thank you for your attention. And I look forward to your questions if there's any time.
Thanks, Ron. So I think we have a few minutes for question. Can you hear me?
Yes, we can.
Okay, so just so. Is there any question from the public?
So what I was wondering about when thinking of the conclusion that Christoph draw, that actually social robots don't work, but pointed to embodiment already. And you were saying AI systems are symbol manipulators as one of the pessimistic regards, because they are no meaning generators. And you would now point to the way out as being the virtual mode. And then I was thinking, if we look at the literature in virtual agents and the community that is quite slightly separate from the HRI community, and the literature in instructional psychology, for instance, I think, haven't they already tried to address that empirically from the notion of the benefit, basically, if we have these virtual tutors in place? I was just thinking about that. For them, this is not new. That has been done in the 90s, but now you put it on the level of the AI system, basically, as one extra layer.
I think that's the best way to understand why I'm revisiting this. It's because something has changed, which is the power and potential of these machine learning approaches. And so I think that a kind of two-pronged approach might actually get somewhere that we weren't able to get before. So maybe the virtual tutoring systems of the past were ahead of their time, that it was an idea that was worth exploring, but they didn't have well, I would say maybe missing two things: missing the AI that would allow that to be exploited, but also maybe, I'm trying to hold out for, you mentioned it yourself. You said that there's a kind of schism between that community and HRI, and I am advocating that the kinds of grounded, if you're not paying attention to what HRI and social robotics has learned, then you're not really providing the kind of grounded meaning that is needed for that kind of system to work. So maybe there are a couple moving parts here. One is what's new is the AI systems. Maybe also what's new is a proposal to take actual robotic embodiment, or at least the kinds of theories and understandings of what counts as being physically embodied with people and machines, and taking that seriously and putting it into your virtual tutors. So maybe we're finally at a place where we can put all three of these pieces together.
Yes, thank you very much for providing that perspective, because it really nicely also fit with the discussion in the panel on other ways of kind of doing our research and going back to the virtual, and now making linking it all together. Thanks very much, Ron, for your inspiring talk. I really enjoyed it.
Thank you.
Maybe I have a question regarding this concept about machine learning doing or making superficial, let's say, decisions or kind of labeling rather than really understanding what's going on. And recently there's this trend in machine learning where people are looking into explainable machine learning. What would you do after you train a model? You kind of open up the box and try to understand what this model used or what kind of features it extracted or used to make those decisions, and whether that makes sense or not. For example, back to your example about maybe the panda and getting misclassified. So if you go to the model and find out what are the real, let's say, authentic, genuine features that help us humans also explain those differences, then probably this would improve the way machine learning systems or models operate in general. So I wanted to hear your opinion. What do you think about this direction?
I agree. I think that one of the limitations on making AI more explainable is that it's making its decisions on a completely different basis than we are. It's not related to our ways of understanding the world, and it doesn't use the notions that we do of causation and purpose and all these different notions that are so rich that even the simplest object around us is imbued with. So for us, so that's why there's such a gap between the basis of its. You could correctly report the basis of its decisions, but that will not be satisfying to us, or won't necessarily be intelligible to us. So a system that does, that is more grounded in a kind of sensory motor reality, or sensory motor activity, at least has the potential of being something we can understand. I have a lot more to say about ways that we can do better on the intelligibility issue, but maybe they would take us too far afield from this topic.
Yeah, and maybe a follow-up question to this, if you don't mind, about this notion of embodiment. Do you think that is because we don't capture multisensory? I mean, I'm taking the engineering perspective. Let's say I'm thinking from it from an engineering point of view. So do you think if I can bring all the 5 senses, which basically humans use to interact with their environments, if I bring all that knowledge or information from all these 5 senses and put them into this virtual agent, do you think that would give it some physical embodiment?
I think it would help, but it's not, I don't think it's the crucial step. So the reason why it would help is that presumably there would be important correlations between what you're getting through the different senses and the underlying reality of the sensory motor dynamic. And so even though you might not be able to pick it up from the just one modality alone, when you have multiple modalities, maybe you can triangulate better. But why do that? Why not instead just explicitly have a role for the body as the nexus of all these sensory modalities, and most importantly, the interaction between those sensory modalities and action, because that's the loop I was talking about. When you have this sensory input, this experience, you respond to it, which changes what experience you have. If I smell dinner being cooked in the kitchen. It prompts me to walk out of this room and go into the kitchen, and that changes the obviously visual and auditory experience, but it also changes the olfactory and maybe even the taste. So there's this coupling of the different modalities, but what couples them is the heart of that story is the place where that happens. The coupling in between those modalities and action is the body. So it just seems that leaving that out would be a mistake. So I would say no, don't settle for mere sensory fusion, but have agents that have an existence that can take action. So an agent that can't take action, well, agents by definition take action. So a system in which there is nothing that is capable of taking action probably will never be able to acquire any kind of intelligence that we would recognize as intelligence. It'll be a mere manipulator or discriminator, what Brian Cantwell-Smith calls a mere reckoner. It doesn't have any ability to judge anything or understand anything. It just has the capability of computing results, of computing the outputs of functions, and doesn't really gain any understanding thereby.
Yeah. And here you're
I hate to sound like John Searle. I don't mean to sound like John Searle, because I don't think I'm not an anti-computationalist at all. I think computation is a crucial component of the story. Obviously, I think AI systems can do this. I think Searle just he understood that mere symbol manipulation isn't sufficient for understanding, but he didn't realize that computers could do more than mere symbol manipulation. I think.
Mm-hmm. Thank you.
So I wanted to thank you for the talk. I mean, you touched so many very complex and deep issues, but also in a very agile and engaging way. And I like to ask so many things, but I'm afraid, because if I touch one of these issues, there are some huge philosophical problems that come out. So just intentionality is something that emerged from sensory motor coupling, or something that pre-exists the sensory motor engagement. Intentionality and computation, is intentionality part of the picture in this, in order to make sense of the world, apart from beyond and above symbol manipulation? Do you have a view about intentionality and embodiment?
Yeah, I do. It's so I don't think it's a matter of being made of the right bio stuff. I don't think that you have to have a certain kind of chemical constitution in order to be have intentionality. Rather, you have to be. I think the most primitive forms of intentionality are where one bit of the world maintains a correspondence with another bit of the world and preserves that in a counterfactually rich way. So if that correspondence is broken, then the system reacts to try and the system reacts in a way that makes it more likely that the correspondence is maintained. And so I guess I'm kind of a Donetian when it comes to it. If the most compelling story account of those two bits of the world is that this one has an intentional directedness towards the other one, it helps me explain so much of its behavior, then that's the true intentional stance in terms of intentionality. He maybe pitched it too high and talked about propositional attitudes. And no, I'm not talking about ascribing beliefs and desires. I'm just talking about, is there an intentional connection between these two things, from this to that? Well, does it buy you anything in predicting behavior of the system? Does it buy you voluminously? Does it give you the ability to explain and predict that system in a wide range of cases? Then there's an intentional relation. So I'm a kind of naturalist about intentionality that way.
Thanks a lot.
Yeah, thanks, Max.
Who is
All right, I think next we will proceed with this session to the next activity, which will be our second panel discussion. Let me just put this on a full screen. And the topic for this panel is kind of trying to look at the pandemic from a slightly different perspective to what has been discussed in the morning, and trying to look for maybe opportunities and applications that could have emerged or been inspired by this pandemic. So let's try to get a little bit more positive, hopefully, trying to at least about the situation. And I think we will be using a very similar approach to the earlier to panel 1 discussion. So we will start by introducing the panelists in alphabetical order. I would like to ask every one of the panelists to introduce themselves. And then after that, we will have a few questions to entertain the discussion. And finally, we'll open up the floor for participants to give them a chance to contribute to this discussion. All right, so I think with that, I would like to invite our first panelist, Professor Jorgen Henke, to give his introduction about himself, about his background.
Yes, hello to everyone. I've been listening since early in the morning, so I found everything quite interesting. And when I contribute to this panel, I will do it from the perspective of having had robots in use in education since 2016. And in fact, I have been using Pepper robots as partners in digital in-class environments since 2016. And I have been using now robots as tools in German schools in the so-called Roboticum since 2017. I think I can contribute with quite some substantial material for your questions later on.
Yeah, that's fantastic. We're looking forward to this. And next, I would like to ask Professor Rahman Lakas to introduce himself, please.
Hello, everyone. My name is Rahman Lakas. I am professor at the Computer and Network Engineering Department at the College of IT in UAE University. And I would like to, first of all, I'd like to thank the organizers of this symposium, and thank Dr. Najjar and Dr. Eid for giving me this opportunity to participate in this exciting discussion about the about social robotics and the effect, or rather the impact of the COVID-19 pandemic on the use and maybe the research on social robotics, AI, robotics in general, autonomous systems. And like for most researchers, we like problems, because problems, they represent challenges for us to investigate them and innovate in some new solutions. And I was happy to listen to previous talk, Professor Chrisley, about I've been doing some AI, but now I discover a whole new face or facets of AI, which is completely strange to me, but I can understand some of its philosophical aspects, and they are inspiring to advance even further in this field.
Yeah, thank you very much, and we're looking forward to your contribution. And next we have Professor Silvia Rossi.
Hi, can you hear me? Yeah,
yes,
okay.
We can hear you.
So I'm Silvia Rossi, Associate Professor in Artificial Intelligence at University of Napoli, Italy. And here we are dealing with social robots, social robotics, from a computational perspective, since we are computer scientists. So actually, this pandemic situation we will discuss later has been a kind of breakthrough in the research, because typically many research in social robotics are used to develop and test things in a very controlled environment. Instead, now we have that we need real application to work in real places. So there was a very fundamental point in our research, I would say. But I will tell you later, we had some things that really worked. So we had some application developed also during this pandemic, and we will discuss later with the others about this.
That sounds really fantastic. All right, and we also have Dr. Eduardo Benitez Sandova.
Hi there. I'm Eduardo Sandoval. I'm Scientia lecturer, associate lecturer at the University of New South Wales in Australia, in the new created Faculty of Arts, Design and Architecture. My background is in engineering, design, and human interface technology. And I have been dipping my fries in different sources of social robotics and human-robot interaction. So I have been working, as the slide states, on reciprocity, human-robot interaction, design and development of prototypes of social robots. And also more recently, I have been exploring the moral aspects and ethic aspects of development of robots with Professor Capuccio. And yeah, pretty much today, I would love to discuss possibilities versus reality in the use of social robots in this COVID situation that we are living globally. Thank you.
Yeah, thank you very much. And I think now we'll move on to the questions. And we've heard earlier from Professor Henke about his, in the introduction, about his work in education and bringing social robotics to the classroom. And apparently one of the biggest hits that we got in this pandemic is our education systems and how they've been disrupted, going from the face-to-face meetings to the online setup. So with that in mind, I would like to ask the question of how you think, Professor Henke, how you think this pandemic has created some good for social robotics, well, maybe from the educational perspective.
Well, I could cut a long story short, in no way at all. The pandemic was absolutely bad for us because there were no more any in-class meetings. And the Pepper robot, for example, took over what we call the classroom application packages, where Pepper takes over certain administrative and technical tasks in class, but there were no classes. So we had to pause that program. So everything that has to do with Pepper as a partner in class has been paused since March 2020, to make that absolutely clear. And there haven't been any further developments. As far as our Now robots are concerned, they are used as tools at German schools, currently at 4 German schools. And here we had some, of course, we were struck by the same lightning. The schools were closed, and in the Roboticum, where we have normally 4 Now robots, 15 laptops, and about 20 pupils per group, we were not allowed to open those groups anymore. However, and this is perhaps, but I don't want to say too much at this moment in time, because you have question number 2, 3, and 4 coming up. Here we developed new strategies. I already posted to you into the chat 2 links, which I kindly invite you to make use of, which on the one hand lead to our project RoboPrax, informing you about what the Roboticum really is. And the second is the link to an online course, which has become part of the teacher degree program at German universities, which uses not only, and this is a little bit ahead of what I will introduce, the virtual robot to an extent which we even didn't dream of a year ago.
Wow, this is really interesting. So maybe we can also hear Professor Lakas' experience about how, if any, how this pandemic has brought in some good to social robotics in any way possible.
My experience is, like I said previously, when for researchers, when there is a problem, for us it's like a new challenge, right? It's something new, and I think despite the fact that it has this pandemic has many other negative aspects, and I think for research it brings new opportunities. And I remember when we the first thing we started thinking about is, of course, I'm not gonna talk a lot about online teaching and all that, so I'm not into that field, but as a teacher, I do face the problem of not being face-to-face with a student. But I think this is just this is my opinion. This is a comfort zone. We need to reinvent teaching and learning, and I think this pandemic is forcing us to think out of the box and looking into new ways of improving learning and teaching. But my field of research is really in unmanned aircrafts or unmanned ad hoc systems and autonomous systems. I'm the head of the autonomous and IoT lab here in the College of IT. So naturally, right away, I think how can I, this is an opportunity in my field to do some research. So I'm not going to talk about drones that we can send and monitor people for whether they are observing the social distance or spraying disinfectant. And we've seen all video clips about all these things. But there are a little bit more subtle opportunities to do research. We know in the beginning, when the pandemic started, there was these, how do we avoid people from mingling together or being in the same place? Or how do we force them to monitor? How do we force them to observe social distancing? How do we push people to avoid touching, use their hands? So the right way, the thing that comes to mind is, can we invent something that that monitor people? Like we can use the smartphone and maybe using some network and communication technology like Bluetooth, and this has already been done, which is to monitor the mobility habits of people. But not only that, check whether people that they have some level of infection, whether they are together or not, doing some AI to learn from the environment and from the habits of people, but also from other aspects like check their breathing, or we actually, as a matter of fact, we're working on a project which is to apply some advanced AI on like coughing, or breathing, and other sensory aspects of COVID, like temperature, and to do that in a pervasive way, and build the knowledge and maybe send alerts to users and to tell them, oh, in that place, there are many people been there, and that they have a highest probability of getting infected, so don't go to that place. So you have like a heat map you can generate that help people avoid certain places, and maybe avoid certain people also, or certain transportation or certain accommodation, and so on. So, but this is, we're looking at it from a networking, a little bit AI and communication perspective. So that's my take.
Yeah, that's great. Thank you. I mean, these are also interesting perspectives and applications that kind of emerged from this COVID-19 situation. And I remember Professor Rossi mentioned about breakthroughs that they're getting in the lab, which maybe they're inspired or kind of the COVID-19 situation has been a catalyst for. So we would love to hear more about that from you, Professor Rossi.
Yeah, actually, it's a breakthrough for getting robot out of the lab, because yeah, because the first thing I see as a positive thing, it's that this situation may have changed the acceptance of social robots in the general sense. Also, the changing the idea of having a robot with us that people might have. For example, we were used to have, I don't know, robots for elderly care, so robot in houses, and then evaluating if they are willing to accept things like that in their houses. But now the same robots are in hospital in COVID situation, trying to balance, to keeping the distance between doctors and patients as soon as possible. So the idea that now this robot can be used, and Professor Lakas gave us a lot of example of kind of application that can be used for monitoring people using these robots. And the idea that in this situation, they can really be deployed in real settings and can help us in a different way would, I think, change the acceptance we have in regard to social robots and the idea that we have about them. But then there is another thing to think about, that social robotics not just only about interaction, but instead I think have many different applications also in service robotics. So for example, after the starting of the pandemic, I received a lot of call of people that want to build up waiter robots or robots to serve us. So the idea to have this robot that whose first goal is not interacting with us, but doing things, is something that is getting a lot of attention. And in this domain, the using social rules, so using what we studied about the behavior of a robot in social context is fundamental. So it's not just building the robot, but also building its behavior in an appropriate way. So I think that that's two things. First of all, taking out the robots out of the lab and making them more acceptable to people, and also using our knowledge also in different domains, such as the service robotics applications.
Yeah, sounds great. So you think that this pandemic situation has helped people to more accept robots in their own spaces?
I think so. I think so. I think I start to look them in a different way. So that's a start. And then we will see how this will proceed. And moreover, just think about also, I talk about weighted robots, but also disinfection robots. We saw a lot of application with the robots going around disinfecting things. But nowadays, this kind of robot have to work 24/7, not only when everything is closed. So they have to work also when people are around. So they do have to employ techniques to behave in an appropriate way with around people. So there's a lot of application where social robotics may give a strong contribution nowadays.
Yeah, sounds great. Thank you very much. This was really insightful. Then maybe we can ask the same question to Dr. Sandoval and hear his perspective or his take on this one.
Right. Well, just getting ready for this talk, I have been doing a little bit of homework, and I discovered that, you know, in terms of social robotics, the main gain that we have is the number of publications. If you do a quick search in Google Scholar, you will find 32,000 publications if you use social robots, COVID, or COVID-19, and then probably half of the results are relevant. And then what I discovered is that, you know, most of these papers are reviews about what people is doing in social robotics. So there are several entries describing what companies in robotics have been doing during the last year. I haven't written a couple of them, so we can notice that there are at least about 200 different cases in 6 different categories of how to use robots for this COVID-19 pandemic. One of these categories, well, these 6 categories are subdivided in 30 subcategories, and many of them are an area of opportunity for social robots. So in that sense, what I noticed that the main game for us is, we have publications, which is a main metric of social robotics. On the other hand, what we have for social robots in this pandemic is a lot of prototyping. I reckon a lot of testing in small scale. And that's a good thing because also we can see our limitations, what areas we haven't been working or further develop in social robotics that are not making these robots broadly available for most of the people. So we see publications, we don't see that many robots, at least not in Australia and most of the countries. And maybe the reason is not necessarily the technology, despite the fact that I truly believe that we still have a lot of limitations in terms of physical interaction, for instance. I guess the other limitations are legislation. For instance, there are crazy ideas that are probably, they break the rules of privacy. For instance, robots taking temperature of citizens, and they are not aware of that. It's a main limitation to put robots in the entrance of hospitals, controlling the ins and outs of users. So considering these things, I see what is happening to many of us as social roboticists is we are, as Dr. Rossi mentioned it, the way that we are seeing the things. But I do a little bit of consultancy with the industry. And what I notice in this process is we are thinking in different philosophies in how to design robots now. Before, I noticed that we were working a lot in general platforms, mainly for research. And we use these platforms to develop particular project to explore a particular variable, sets of variables in experiments in social robotics. Now I reckon, at least my very limited subjective experience is that people is thinking in more specific developments, more one task oriented robots. And of course, that's also happening in the academic framework, which probably we will discuss a little bit later.
Sure. Yeah, I mean, that's great. And what I hear here is that there's some good stuff coming out, maybe from a need, from a necessity, from this pandemic situation. And I think now we would move on to the second question. And that question is trying to analyze or better understand how the social robotics community can be inspired even beyond the pandemic. So hopefully soon, as the vaccine is being disseminated worldwide, hopefully this will reach an end soon. And until then what we would have learned from this and how that pandemic would shape us and help us develop for and be better prepared for the post-pandemic era. And I would like to start with Professor Henke about his opinion about this.
Well, in our Roboticum, as I said, we are serving students and pupils from all sorts of classes, from the 5th graders to the 13th graders in the German secondary education school. And we had the problem at the very beginning in March 2020 that the schools were simply closed down and there was no option to do that Roboticum anymore. But then after some time, we had created enough material to do 2 things. On the one hand, we were increasingly using the option in Choreograph, the developmental environment for now robots, to use the virtual robot. We could simulate human-robot dialogues. We could simulate robot movement, animations, body movement, and motion. What we could not simulate is object recognition. So we had to go and opt for a sort of slimline in-class roboticum, which we were allowed to do in smaller cohorts. And that, of course, required to strengthen our online options. And this is why I invited you to the class Robot Teach in my link in the chat to simply use that class. It's free, it's open, you can use it. And we developed programs for the virtual robot. That was a very important new thing. And now we have a number of such programs that even in the post-pandemic situation, we would like to use those instead of doing everything in class. The other thing was we developed new communication tools. The situation in a roboticum requires that there is some sort of coach. We don't call this person teacher anymore because there's nothing to teach. There is coaching in the new digital teaching and learning environment, that the coach has access to the screens of the students. Now, in a normal situation, the coach would simply walk around. At the moment, this is not the best option, as we all know. So we're using telecommunication tools like TeamViewer and other things where we share screens, show them to others. And so we had to redevelop these tools for proper in-class meetings. And I can tell you it works. And the third thing is that more and more schools are interested, including the United Arab University in Al Ain, to erect such a roboticum according to our principles. And so it seems that this pandemic not only has erected new roboticums, I never know whether this is the correct plural, new roboticums in Germany. In our environment already we have 5, and there are no more states interested in Germany to erect the same thing. 4 robots, 50 laptops, infrastructure, and the online courses to go with them, and possibly the same for Al Ain in the time to come.
Yeah, that's fantastic. That's great. I mean, it's very interesting to see how this pandemic has kind of inspired us to find innovative ways of communication online, or maybe educational systems online. That's really great. And then I would like to ask Professor Lakas also to bring his opinion about this question, probably from the Internet of Things, from the drones perspective. How do you think some of what you're thinking about during the pandemic could be also utilized and live further beyond?
Yeah, sure. I think, you know, the pandemic, one of the positive things is that there is one thing, which is the resistance to machines and robots, and started fading away, the resistance of people in society in general. So, and the other thing is that almost 2 years now, this pandemic forced people to adapt new habits and new behavior towards their interaction, the relationship with robots, and not always the best one, but there is a lot to be done. But these new habits make us a society and users prepared so start accepting more involvements of robots in our lives, right? So, but then again, we have to realize that there is a market, and most of the time, if it's not all the time, the market is the one that drives research and drives. So we know that, for example, universities, schools, the industry, people been working from home, kids been learning from home, and this could be, from a cost point of view, it can be very luring for the industry and for the market. So I expect there will be a push for more online, more people working from home, more student learning from and training from home. So that's what I'm going to see. But from in my area, of course, in general, in robotics and like in my area, I work mostly on ground vehicles and unmanned ground vehicles and unmanned aerial vehicles. There is absolutely an increasing need for these machines for specific tasks. But if you look at it from a general perspective, I think even when this pandemic goes away, we're going to be do more online. There will be some percentage. For example, a school. I think our kids they got used to staying at school. Of course, they miss going to school, but they get used to do learning from home. And maybe the time where they go to school can be replaced by other also beneficial learning, for example.
Yeah, thank you. Thanks for that. I think I would ask the same question to Professor Rossi to hear her perspective on that.
Yeah. I kind of agree with Professor Lakas. There is a strong need of robotic application nowadays, but from a social robotic perspective, the takeaway message would be to keep it simple but working, let's say. Mm-hmm. So instead of trying to evaluate complex things that instead are teleoperated or are simulated, let's try to have few things, but that can be easily deployed in the real world. So even though we have to test few peculiarity of our system, but let's try to take advantage of the collaboration with the automation, with the computer scientists, or with other colleagues in order to have things that can be easily deployed and have an impact, of course, on the people's lives. Yeah. So for the social robotics, it would be, it's not like take a step back, but it's try to get more towards the real world.
Mm-hmm. So it kind of accelerated this transition to the real life. Yeah, that's great. Thank you very much for this. And then Dr. Sandoval.
Yeah, well, I was thinking a little bit about the possibilities of social robots over other technologies. If it's
so the question is, how do you think this pandemic has created opportunities to social robotics that can long live beyond the pandemic, that can be useful for the post-pandemic situation?
Right. Yeah. As I was mentioned, I see a lot of possibilities in lifestyle changes. That particular category for social robotics is good. And from my perspective, something that is a very, very interesting problem is fatigue and overuse of screens. I reckon we rely a lot in the screens for Zoom, and that creates a lot of cognitive load, visual fatigue, auditive fatigue. As you can notice, I'm not a big fan of screens because once that you have 6, 7 Zooms per day, it starts to be not really convenient. And when you have a screen between you and your loved people or your colleagues that you see in conference every year, you start to notice that, yeah, it's convenient, but it's not the best way of interacting, I reckon. In that sense, the embodiment that the social robots provide offer a lot of possibilities for activities that don't rely in screens. And in that sense is how I have been reframing my own research and trying to find new possibilities in natural human-robot interaction, aiming a little bit more physical interaction, but also more oriented to the task. In the years coming, in my case, I want to explore more how we can engage with the robots outside of the experimental room in the long term. And the main question there is what kind of task, what kind of activity could work in that sense. And there are several examples of this kind of behavior with previous technologies. Video games is one of them. Like they can reach the level of even addiction. I reckon recently has been recognized as an addictive behavior. And also, in opposition, apps. It's very well known that the business model of several apps is that you buy an app or you buy the membership for an app, and you never use it. Like 90%, 98% of people who buy exercise apps, including me, they just buy the app and never use it. Maybe with a social robot, for instance, could be a better way because the physical presence of the robot to engage in these kind of activities. But again, my main concern is we need to improve the physical skills or the physical abilities of the social robots beyond the verbal interaction to make more meaningful interactions.
Yeah. Thank you. This is really interesting ideas. Thank you. Thanks for sharing this with us. And maybe I can take the third question. And this is more about describing a personal experience. If you have had any experience of maybe something that has happened that inspired you to think about an interesting application that could come out of this COVID situation. And I will go back to Professor Henke for this.
Well, yes, we had a few things that we observed. First of all, probably like in other countries too, we saw that there are enormous deficits in the digital approaches of teachers, school teachers. They are really struggling a lot, which is due to the bad education at German universities. I must admit, I'm part of a university and I'm partly responsible for that. We hadn't done enough in the past to educate our teachers so that they can cope with the digital world and digital teaching and learning scenarios. That strengthened, of course, our approach to introduce the makerspace idea with robots to teacher training. And it has become, since the end of 2019 now, an integral part of our teacher training at school, at university. And this is, by the way, the online course for which I gave you the link. That's the online course for teachers in order to be able to control the roboticum later on. The second thing is, and I think this distinguishes us a lot from other applications, in our applications, the robots have to run all day, not just 5 minutes for an experiment, but for a day. And if you do that, you find enormous deficits in the hardcore programming of the robots themselves. One thing where I would reply to Silvia Rossi, for example, is we had so many requests by storehouses and supermarkets to make use of our robots. And I told them, no way, they're not reliable enough, they're not autonomous enough. What is the use of a robot where you have to have 2 human programmers standing behind them? No way, we didn't do that. We found flaws and bugs in the programs, which means now we are in permanent contact with SoftBank Robotics, with the programmers, to get rid of the bugs in the programs. We cannot afford to have one bug if we want to use now robots for 5 hours without end. So that's another thing, which was our personal experience. And as I said earlier on, the strengthening of the programming of robots. So we're working with now robots as tools. As Max Cappuccio explained earlier on, the use of robots as tools. We're working on the robots, not with the robots. And that means they have to be reliable, totally reliable, which is not the case. At the moment, I must admit, now robots are not reliable, but they will possibly become reliable because, as I said, our programmers have contacted SoftBank Robotics and we will erase a number of such unreliable aspects. By the way, we're using now version 6 robots, the new ones. They're less reliable than the now 5 robots, the red and blue ones.
Oh. Thank you. Thanks for this great contribution. And I would also ask a similar question to Professor Lakas about any personal experience that has inspired you to think about some interesting novel applications that could
Yes, actually, I just want to comment on what Professor Henke said about the reliability of the robots. I remember the first, when the pandemic starts, all the services, even public services, and some companies, they asked their employee to stay at home, and then they put in their website this chat bot that can provide you service or answer any question that you may ask. And I found that I hated it because I couldn't communicate properly with that robot. And I remember I wanted to increase my internet speed because of the need, and I couldn't get myself. You know, it was like a special situation that robot was not trained for. So I do agree that we need to work on that aspect. But some of the idea that came to us when this pandemic started is, for example, to have to augment or to extend the personal assistant that we may have embedded in our phones with the ability to monitor you and to monitor your mobilities and monitor. I already talked about this, which is to monitor where you go and who do you meet, and of course you can using Bluetooth or Wi-Fi, you can there is a way technology allows us to know where you are. We have GPS to know who the people are around you. You can detect that through either Wi-Fi, Bluetooth, or other means of communication, and you can build some kind of knowledge of your environment and how you are interacting, how you are progressing, evolving in that environment, and gives you kind of advices on how to deal with situations. So it could tell you, well, this place, and of course, this application should be cooperative, and many people should participate in it and share their data in an anonymous way. And the idea is to provide you with advice where to go or the places to avoid. So this was, we thought at the beginning, but we were looking for the fundamental problems, not the technology problems, because there is a lot of, so you're kind of building a graph of relationship, and then which is a probabilistic graph. You would like to say, well, there is today there is a chance of 50% you get infected if you go to that place, you go to that market, or you go to, but this is based on information that you collect from previous, from data, previous, previous historic, the past historic, right? So this was the idea. The other idea, we had a previous project, which is using drones for search and rescue. And we use a technology that is capable of detecting victims of disaster or earthquake or catastrophe. And through the signal that is emitted continuously from their devices. So, and we thought we could do the same thing to embed or to equip a drone with this technology, so we can detect the presence, the mobility of people in, especially in certain, like coming out of stadium, or if there is a place, a crowded place, or entrances of the trains or train stations, metro stations, and then to kind of build a knowledge about the proximity of people, and possibly send a recommendation to for example, incite people to observe. So this is some of the ideas that came to mind when yeah.
Thank you very much. Thanks for that. I would also now invite Professor Rossi to provide her perspective on that same question about personal experiences. Yeah.
Yeah, actually, I don't have an idea of possible new application, but I do believe that we have to change the approach for developing application. So, for example, just before the start of the COVID-19 situation, we had this experimentation with very cheap robots, so even more unreliable with respect to the paper or now or stuff like that, to monitor and to entertain elderly people in their own houses. So we had these robots built up by composing simple services. So the idea was to have different things that you can match together, personalizing with respect to the user. So you can have navigation, you can have interaction. So you just have this kind of small pieces that you can put together as you need it. This kind of approach to it's like developing apps, no? for a mobile phone. So this kind of approach, when the pandemic started, allowed us to take the robots and put them in the hospital, because we could match the behavior that we can use in the situation and let them go. So they are still running in the hospital in Varese in Italy. So again, if we just start thinking more from a computational point of view, so we don't have to build complex things, but putting together simple things and personalize the things that we want to use in a robots with respect to the application, with respect to the user, so we can have small things working and put them together as we want in order to have personalized application running, even if they are simple, but really running on the robots in a sort of reliable way.
Yeah, simplicity and applicability or practicality of their work.
Yeah, modularity. So we have modules that can be put together. Yeah.
Sounds great. Thank you. And now I would like to ask Dr. Sandoval to also contribute his perspective on this question.
Sure, Mohammed. Well, from my perspective, one of the issues that we also see in these pandemic times is mental health, particularly anxiety and depression. Australia was one of the first countries that put in lockdown the population. Here, citizens and residents trust the government and they immediately follow the guidelines. But very early, we start to see as well a lot of mental health problems, particularly anxiety in young people and also adults and so on. And one of the problems is that we have hotlines for mental health, Beyond Blue and Are You Okay? So if you are depressed or you want to hurt yourself or you think about suicide, you can call them. The interesting thing is that you require to call them and you will have an appointment after 2 weeks, which is probably very useless in that kind of urgency. So in the same sense that Dr. Henke was citing the undersupply of teachers, there is an undersupply of professionals in mental health. So what I see there is that this is a problem that a chatbot or a social robot cannot sort out. However, under the philosophy of virtuous robotics, maybe social robots can help to minimize the problems, particularly anxiety, by other ways. For instance, there is a very strong correlation that one of my colleagues at UNSW, co-author as well, Simon Rosenbaum, has been investigating the strong correlation between exercise and mental health. For instance, 10 push-ups when you start to feel anxiety actually have a certain impact in reducing or minimizing the anxiety. However, the main problem with the users or with humans is they don't build these habits easily because that implies an effort. It's another cognitive load that we have. But maybe with an agent, maybe with a social robot, could be possible to build these habits, could be possible to minimize these mental health problems. Hence, probably we can have a more suitable demand of mental health services in the future. So this is the kind of things that maybe that sounds like a grant application. Probably we should work on something like that in the future.
Yeah. Great. Thank you very much. I think these were very inspiring observations. And I think for the sake of the time, I'd like to turn to the audience and ask if anyone has any questions. And I've already seen that there is one in the chat box, and I would kind of try to summarize it. And this is interesting because it refers to what we've been talking about lately about, for example, mental health, loneliness in particular. I think there is a reference to this in the pandemic. So the question is, I would read this. I would be interested in hearing the panelists' thoughts with regard to the aspect of loneliness during the pandemic, also playing a role in increasing anthropomorphism towards social robotics. So anybody would like to take on this question?
Yeah, I do agree that another factor changing possibly the acceptance of robots, it's the loneliness. People are, of course, lonely in this period. They're forced to stay alone in their house, especially old elderly people are kept in their house, isolated from the others. So nowadays, the idea to have devices that help us also to interact may be a good thing. Yeah. I'm just imagining my parents will probably, they started this lately to use a lot of things they never used before. So they start to make video chat, they start to make calls. They were not using this kind of technologies beforehand. So in this period, also also robots may be accepted more due to loneliness, due to isolation and distances, social distances.
Yeah. Thank you very much. I mean, I think it was about a week or two that I read in the news that there is this company called Fun for All that has found a surge in their sales. They make social robotic pets, pet robots, and they're kind of now overwhelmed with the queries about the robot, and it's not very expensive. I think it's about less than $150, but it seems like a lot of people have put a request or a purchase order for this.
Yeah, but may I add also that lately I've been making a lesson with children in the like 8-10 years old, and I always ask them what would like an application for robots, and I was expecting, I don't know, a robot that made my homework, stuff like that. And a lot of them replied, robots that play with me.
Yes.
So even for children, the isolation and being separated by the other companions is something that's really sad, but it's something that's true.
Yeah. Very interesting.
I think just to look at the positive side of this, I agree with Dr. Rossi that we don't want to create loneliness. For people that do not need to do social distance, then that's fine. But definitely social robots can be very helpful for people that are already lonely, even without the like elderly people or like some. So we can see from that aspect. So maybe the pandemic put us in a situation where we become lonely, and then we can understand the people that are lonely, so we can try to innovate and create something that can help their loneliness. I definitely agree with Dr. Rossi. That's true. Our kids are in a situation now where, but I believe that there is a middle ground between. It's like for any technology, right? So there is good uses to technology and bad uses for technology.
Yeah, thank you. And I see also another question on the chat box related to the cost, and this goes to Professor Henke. And the question is about Do you think these AI solutions are that are being in schools aren't very expensive? And if yes, how do you cope with the situation of COVID-19 that shaped already the economy of countries? So it seems like everybody is trying to save money now. So how that would work out, in your opinion?
Yeah, I already saw the question on the chat and answered it very quickly. Question one was, my answer was 23,000 euros for 4 Now robots. And this is, at least in Germany at the moment, nothing, because they're investing far more money into tablets, which I think is a disaster, by the way, because they will not be used anymore in 2 or 3 years. So, but the robots will. They last a little bit longer, I think, and the robots can do much more. And that's the answer to the second question: what is the gain? The gain is, of course, and here we are again with the embodiment, the social contact with the robots. The children and the pupils of whatever age, they are fascinated by using a robot and not just a computer screen to learn programming. And then here, something very positive: Choreograph, a visual programming environment, is really fantastic to be used in this context. It's not a good environment for programming real modular robot application in the sense of our classroom application packages or something like Silvia Rossi mentioned earlier on. But for learning programming, it's a wonderful environment. And so I think the gain is really clearly visible. And our research, we're doing research on humans, by the way, not on robots. We're asking the pupils what is their reaction. We found at least one thing which couldn't be found in the past, namely that girls and boys are equal in such classes. There are no gender differences anymore. In the past, you would have possibly seen the computer nerds in such classes. But if you go into such robotica with a full class, then there's no difference anymore. And so I can only see very highly positive things, apart from all the other things like dealing with data, dealing with folder structures, and so on and so forth. So there's a lot more to learn than just simple robot programming.
Excellent. Thank you very much. That's really great. And I would like to ask if any of the audience have any more questions. I think we're going a little bit beyond our time schedule. So if not, then maybe we'll move on to the next slide, and that is the announcement for the 7th joint UAE Symposium on Social Robotics. Before talking more about this, I would like to extend a very special thanks to all the 4 panelists on this on this discussion. It has been really great. I really enjoyed it. I've learned a lot, and it's really interesting to see how this pandemic situation has created opportunities for us to rethink about even some methodology, some research methodologies. I think that was really interesting. So with that, I would like to share with you some really very exciting news that our 7th Joint UAE Symposium on Social Robotics will take place on the 6th to 9th of February 2022, and that will be hosted with Expo 2020, which has been postponed to Expo 2022. So we're looking forward to see, hopefully, all of you in person in Dubai next year in February.
And can I add something, Mohammed, if you allow?
Yes, please go ahead, Farid.
Yes. First of all, I would really thank you, Mohammed, for managing very professionally the session. And thanks for all the organizers, Federica and Max. Sorry, I know Federica like us to call in a family name, but guys, I love you. I mean, we are friends at the end. And I really like to thank all the speakers and all the panelists for joining in the last minute call. We were actually in between organizing or not the event because of the many logistic issues. I would love really to thank everybody for accepting us and accepting to be speakers. Thanks, Dr. Ron and everybody. And for the Expo 2020, it will be a very special event. It will be actually, it will be for 6 days. It will be 3 days. It will be managed by the Australian Pavilion, and another 3 days it will be from 3 to 6, and it will be managed by the French Pavilion, and it will be in collaboration with Soft Robotics. And me and Jorgen will be presenting the first style of this robots that will be in a classroom, so people will have the experience of being around with the robots as a teacher or as a TA. And we have a special, I mean, we will arrange 6 days stays for all the speakers. Hopefully we will get discounts for audience to stay with us in Expo 2020. Inside, we are planning to reserve the rooms inside the Expo hotels. So I believe it will be a very nice experience. Hopefully we will do it without masks in 2020 too. And yes, I'm very happy for seeing everybody here, and thank you really very much for the events. If you would like to say words, Muhammad.
Yeah, I mean, you've said it all, Fadi. Thank you also for your contributions. I actually wanted to thank all the speakers, all the contributors to this event. It has been really great. And also I wanted to extend this thank you to the organizing committee, Frederique, Max, Fadi, and finally, I would also like to acknowledge and thank our audience for joining us today. I mean, it's more than 4 hours now that we are sitting in front of the screen, and I really appreciate, and we really appreciate your passion about this topic, and we're looking forward to meet all of you in person, hopefully next year.
Thank you very much. Maybe Federica would like to say something?
No, it's all fine. I'm looking forward to see you all in reality in nice and warm Dubai. All the Europeans will appreciate that in particular. And I'm really happy that even though we had to do the virtual mode, the COVID-19 mode, it was a success, and it was great that you nevertheless joined us with the joy. So to the next.
Oh.
Yeah.
Okay, Federica has a few internet issues, I guess.
Yeah. Hopefully next year we won't have any of these issues because we will be in person. So until then, we wish everybody a very healthy and a very safe times, and hopefully we'll get to meet you in person again next year.